Welcome back to the deep dive. For years, really, we've talked a lot about the incredible technical side of AI, the large language models, the speed, the prediction power.
hmm
But today, we're shifting gears. We're moving beyond just the technical, how it works, and uh, getting straight into the really profound ethical choices, the choices institutions are making right now as they bring AI into higher education.
Yeah, it's a necessary shift, isn't it? Because, look, technical brilliance, that doesn't automatically mean responsible use.
Right.
You can have the most advanced, sophisticated AI system out there, but if that system just keeps reinforcing bias, or if it violates student privacy, or, undermines trust, well, it's a problem. It actually fails the educational mission itself.
And these aren't just like philosophical debates happening off somewhere.
No, not at all.
They show up in real high-stakes decisions every single day.
Hmm.
And an institution decides, okay, we're using AI to evaluate student writing.
Or to flag students who might be at risk of dropping out.
Exactly. Those choices are shaping fairness. They're shaping opportunity right now.
So our mission today really is to give you a clear map of that ethical landscape. We want to move past the abstract stuff and focus on practical frameworks, ways to spot and tackle these challenges before they get baked in.
Okay.
And we're starting with a really practical foundation, one that's especially relevant for diverse places like community and technical colleges. It's called the AEIOU Framework.
AEIOU. Okay, I like that. Let's unpack this. The idea of turning complex ideas into, well, strategies you can actually remember and use. That sounds good. So let's start with A. What's A in AEIOU?
A is for accessible, and this is like a fundamental equity check. If AI tools are supposed to help all students, then they have to be usable by everyone, regardless of ability, sure, but also socioeconomic status or the kind of tech infrastructure they have access to.
So we're talking about more than just, say, screen reader compatibility here. It's about basic hardware, too. Can my old laptop run this?
Exactly that. If your fancy AI system needs the very latest browser or a super high-end laptop or requires a constant blazing fast internet connection,
You're immediately cutting people out.
you are. You exclude students using older devices or relying on, say, public library Wi-Fi, or maybe they have limited mobile data plans. Accessibility means designing tools that work reliably even if connectivity is spotty. If the tech only helps the most privileged, well, it's failed.
That makes total sense.
Hmm?
Okay, next up is equitable. So this seems to move beyond just, can I use it to, is the outcome fair?
Precisely. Equitable means that AI has to actively work to address bias, not just reflect or worse, amplify the systemic biases that already exist against underrepresented groups.
How do you ensure that?
Well, it means institutions have to commit to constantly checking how the AI performs across different demographic groups,
Yeah.
auditing it, making sure the outcomes are fair and balanced. If you don't look for bias, you basically guarantee it's there.
Got it. Then we have inclusive. How does that play into the development part?
Inclusion means the whole design and rollout process needs diverse viewpoints baked in. You can't just have like 5 data science PhDs in a room designing an AI writing coach.
Right.
You need input from the students who will actually use it, the faculty who will grade based on its feedback, the staff managing it. Without all those different perspectives, the tool is just going to end up serving a pretty narrow slice of the student body.
Okay. And moving to what feels like the bedrock of it all. O is for open.
Yes, openness, transparency, and accountability are key here. We need to get rid of that black box problem as much as possible.
Explain that a bit more. A black box.
It just means the system's inner workings are hidden, opaque. Students and faculty need to understand, at least fundamentally, how these systems reach decisions that really affect them, whether it's a grade, a flag for financial aid review, or a risk score.
Makes sense. And wrapping up the framework, the final letter is U, universal.
This one is so critical for higher ed broadly, but maybe especially for places like community colleges. Universal means AI solutions have to work well across lots of different educational settings.
Because the student body is so varied.
Exactly. You've got recent high school grads alongside returning adults changing careers, their backgrounds, their goals, they're all over the map. A one-size-fits-all AI tool designed for, say, a traditional 4-year university,
Yeah.
it's probably going to misunderstand or just fail to serve this really complex group of students.
That framework, AEIOU, it gives us a really useful lens, doesn't it?
Yeah.
For looking at the huge challenges ahead, especially algorithmic discrimination.
Absolutely. And now we shift from those guiding principles to the problem they're designed to solve, algorithmic bias. And this isn't theoretical, it has real, tangible impacts on students' opportunities, their outcomes. And honestly, the numbers here are pretty stark when you look at the studies. Studies looking at these student success prediction algorithms, the tools supposedly helping students found they produce false negatives for 19% of Black students and 21% of Hispanic students.
Whoa, hang on. Let's break that down. A false negative means the AI predicts the student will fail or drop out.
But they don't. They actually succeed.
So nearly 1 in 5 Black or Hispanic students who do succeed are being told by the machine they're likely to fail.
That's right. And when that happens, think about the barriers it creates. Maybe they get overlooked for certain programs. Maybe they're pushed into remedial classes they don't actually need, or they just get this inaccurate label stuck to them. It impacts their whole journey.
Okay, this is where it gets really interesting, I think. Why? Why does a supposedly neutral algorithm get it so wrong for these students? You mentioned breaking down the sources of bias. Let's start with the first one, training data bias.
Yeah, training data bias is probably the easiest one to get your head around. If the data you use to teach the AI doesn't fully represent your current diverse student body.
How might that happen?
Well, maybe the data is old, from a time when demographics were different. Or maybe it's mostly drawn from traditional age students, so the AI just doesn't learn what success looks like for, say, adult learners or students juggling work or recent immigrants. It's basically learning from an incomplete picture.
Okay. But then you also mentioned historical bias. How is that different? Isn't that still about the data?
It is about the data, but it's a crucial distinction. Training data bias is about who's missing. Historical bias is about the flaws already present in the data you do have.
Ah, I see.
So if your AI learns from, say, 20 years of grading patterns where faculty, maybe unconsciously, undervalued certain cultural writing styles, or if it learns from admissions data that historically favored one group over another, the AI doesn't see bias, it just sees a pattern.
And it replicates it.
It replicates it perfectly efficiently. It learns the discrimination that was already baked into the system.
Right. And the third source.
That's design bias. These are the assumptions that creators build into the system from the start.
Like what?
Well, imagine developers assume that logging in and doing work consistently every single day is the only real sign of engagement or success. That design inherently disadvantages a student who maybe works 2 jobs and does intense catch-up sessions on the weekends. The way it's designed just doesn't match the varied realities of student lives.
And we see the fallout from this everywhere, don't we? Automated essay scoring is a classic example. Systems showing bias, giving lower scores for the same level of thinking just because of writing style differences linked to demographics.
Oh, definitely. And there was even this really striking study on AI used for generating educational scenarios like images and stories.
What did it find?
When the AI was asked to depict students who were struggling, it overwhelmingly showed students of color. Ask it to show successful learners, predominantly white characters.
Wow.
So the AI wasn't just reflecting bias, it was actively, visually reinforcing harmful stereotypes.
So the solutions have to tackle all of this.
Right.
We need diverse data, yes, but also things like bias auditing, diverse development teams, and keeping humans in the loop. But addressing bias often means feeding the system more student data, right?
It often does, yes.
Which leads us straight into the next big ethical minefield. Privacy and surveillance.
Exactly. The sheer amount of data these predictive AI systems consume is just unprecedented. It goes way beyond traditional records like grades and attendance logs.
We're talking at a really granular level of detail here. AI systems analyzing subtle things like how a student's writing style changes over a semester.
Yes, or their detailed study habits, how they manage time, patterns of social interaction in online forums, and this is the one that always gets me, potentially inferring a student's emotional state just from their text interactions.
That's chilling.
It is. And all of this gets rolled up into these incredibly detailed student profiles.
Which immediately raises huge concerns. Starting with consent. How voluntary is it, really, when opting out means you might fail a required course or get excluded?
That's the core of the power dynamic, isn't it? It feels less like informed choice and more like, well, coercion.
And security. Centralizing all that sensitive data must make it a massive target for hackers.
A huge target, highly attractive. And then there's the whole issue of third-party vendors. When institutions outsource AI tools, what happens to that student data? How is it stored, used, protected once it leaves the institution's direct control? These are critical questions.
So if you're a responsible institution facing this data deluge, what safeguards absolutely have to be in place?
You need strong, non-negotiable protections. First, data minimization. Only collect what is absolutely necessary for a clear educational purpose. Less data means less risk. Simple as that.
Okay.
Second, purpose limitation. Data collected for one thing, like grading, can't just be reused for something else, like maybe marketing job opportunities, without getting explicit new consent.
And how long do they keep this data, especially the really sensitive stuff like inferred emotional states?
That's where clear retention policies come in. You absolutely cannot keep detailed records like that indefinitely. There have to be limits. And finally, really rigorous vendor management, making sure every outside partner meets the same high privacy and security standards the institution sets for itself.
That focus on protecting data, it leads directly into trust, doesn't it?
Yeah.
Which gets totally undermined if decisions are made inside that black box we talked about, if you can't see why a decision was made.
How can anyone trust the outcome?
Exactly.
If the model is opaque, even to the people using it within the institution, it just creates this massive crisis of confidence.
Yeah.
Imagine you're a faculty member, right? An AI tool flags one of your students as high risk. You try to intervene, help them out, but the student asks, reasonably, why? What specific things made the system flag me?
And the faculty member has to shrug and say, I actually don't know.
Precisely. Or think about a student trying to appeal a decision they think is wrong. How can they prove the system didn't use inappropriate factors, maybe their zip code or some outdated piece of data? Without ways to audit, verify, and appeal, trust just evaporates. The system stops being a support tool and starts feeling like this arbitrary judge.
So this really pushes institutions to define what makes AI trustworthy in their specific context. What are the key characteristics we need?
I think there are 5 core things. The AI needs to be reliable, performs consistently, doesn't give wildly different outputs for similar inputs. It has to be accountable, clear ways to fix things when they go wrong. It must be transparent. Its logic needs to be understandable, at least to the relevant people. You don't need the source code, maybe, but you need to grasp the why.
Okay.
It has to be fair. The outcomes need to align with the institution's values around equity. And finally, crucially, it must be respectful of human agency. It needs to preserve space for human judgment, for intervention, especially in really important decisions.
Let's pivot slightly now to an ethical angle that, frankly, often gets missed in these tech discussions in higher ed. The environmental cost.
Yes, this is so important.
The massive computing power AI needs translates directly into significant energy use and, well, a real environmental footprint.
And this creates a fascinating, maybe uncomfortable tension. So many institutions have strong commitments to sustainability, right? Climate goals, green initiatives.
Right.
Yet some of the very tools they're adopting are incredibly energy intensive, running counter to those goals.
Can you give us a sense of the scale? Is it really significant?
Oh, it's significant. Just look at the training phase for one well-known model, GPT-3. That process alone chewed through about 1,287 megawatt hours of electricity.
Okay, what does that mean in real terms?
It generated roughly 552 tons of CO2 emissions. To put that in perspective, that's like powering 120 average U.S. homes for an entire year, just for training one model.
Wow, and that's just the training.
That's just the upfront cost. Then there's the constant electricity drain from the data centers running these things 24/7, the energy for cooling those centers, plus the manufacturing of the hardware. And every single query, every time someone uses the AI, it consumes more energy. It all adds up.
So connecting this back, institutions really have to square their green commitments with this push for AI innovation.
They absolutely must. Responsibility here means making ecology a core factor when they decide which AI tools to buy or build.
Hi.
By prioritizing applications where the educational benefit is truly clear and transformative, not just a novelty. By demanding that vendors use renewable energy sources for their data centers. By working to optimize how these systems are used to cut down on wasted computation. The environmental cost has to be part of the equation, weighed seriously against the benefits.
Okay, so we've talked principles, problems like bias and privacy, trust, even the environment. Let's talk solutions at the institutional level. To manage all this ethically requires some kind of formal structure, right? Governance.
Sure.
Who needs to be at the table?
Yeah, governance can't just live in the IT department. That won't work. It needs broad, cross-disciplinary input. You really need established AI ethics committees,
Made up of
faculty, administrators, ethicists, maybe legal counsel, people who can evaluate proposed AI uses against ethical standards and actually set policy. You also need technical review boards, folks with the deep expertise to really assess what a tool can and cannot do, its limitations, its potential biases.
And critically, where do students fit into this governance picture?
They have to be there. Meaningful inclusion of the student voice and community input more broadly is absolutely crucial at the policy level.
Because they're the ones most affected.
Exactly. They're the primary subjects often of these systems, their experiences, their consent concerns, their feedback. It has to shape how these tools are deployed. You can't govern ethically without them.
So these committees and boards develop policies. What specific areas do those policies absolutely need to cover?
Well, you need clear, acceptable use guidelines, obviously. Robust data governance is vital rules for collection, use, sharing, retention. But beyond that,
Yes.
policy must spell out human oversight requirements. When is human review absolutely mandatory before an AI-driven decision takes effect, especially for high-stakes outcomes? And maybe most critical for maintaining trust over time, clear, established appeals and remediation processes.
Or when things go wrong.
Yes, if an AI system makes a mistake, flags a student incorrectly, causes harm, there needs to be a clear, accessible path for that student to get it fixed.
So governance sets the structure, the policies set the rules. But ultimately, success comes down to individual responsibility too, right? The
Yeah.
faculty and staff making choices every day.
That's exactly right, because even with the best policies, the ethical rubber meets the road in daily practice. For faculty, it means constantly thinking about academic integrity. Is this AI tool helping the student develop skills, or are they just becoming dependent?
Good question.
It means thinking about fairness. Do all my students have equal access to these tools?
Yeah.
In transparency, am I clearly telling students when AI is involved in grading their work, providing feedback, or influencing other decisions about them? The institution provides the framework, but it's those daily conscious choices by individuals that determine if AI truly serves our educational values.
So this deep dive has really shown how interconnected AI ethics are. You've got the AEIOU Framework as a kind of blueprint, and then actively tackling bias to prevent harm, strong privacy measures to protect students, transparency to build trust, and now even considering the environmental impact. It's a lot.
It is a lot, and it shows that the future of ethical AI in higher education really depends on two things working together. Proactive institutional commitment, setting up the governance, the policies, and diligent daily ethical practice from faculty and staff who are constantly looking at these systems and asking, is this actually helping us achieve our educational mission?
Okay, I want to leave you, our listener, with one final provocative thought to chew on. We talked about the environmental cost. Remember that GPT-3 training example? 552 tons of CO2.
Equivalent to 120 homes powered for a year.
Right. So given that substantial carbon footprint, just for training these complex models, let alone running them, how can institutions ethically justify deploying these massive AI systems unless the educational benefits are genuinely transformative, unless they offer something profound that truly cannot be achieved through less computationally intensive means? That tension between the drive for innovation and the ecological cost, that feels like the next big frontier for ethical decision-making in education, something to think about.